Hi, this is Claire, and today we're looking at finding theta using the trig ratios SOHCAHTOA. Now, if I asked you to draw a triangle with a right angle, okay, the hypotenuse length is 10 centimetres and one other side length, let's make it the opposite side length, opposite the angle in question. We're going to make it 5. So here we go. Here is the opposite side length of 5 centimetres. It forms a right angle. And here's the right angle. So that's 5. Just drawing the right angle. Now the hypotenuse is going to be 10. But I want to be careful that I keep this right angle. So here's my 10 and I'm going to make sure that it fits the base. So that's 10. Can you see there's only one possible triangle I can draw? If I ask you to draw a right angle triangle, I don't know what any of the angles are. I'm not telling you what the angles are, but the height here is 5 and the hypotenuse is 10, there is only one triangle you can draw. There's only one way I can join these two ends of the lines together, and I form a right angle triangle. So if I wanted you to find this angle here, theta, an unknown angle, and we have the opposite and we have the hypotenuse, what trig ratio links theta, the opposite, and the hypotenuse? It's sine. So sine theta equals the opposite length divided by the hypotenuse. Sine theta equals, in this triangle, the opposite is 5 and the hypotenuse is 10. Okay, so because there is only one triangle and we have two pieces of information, there's only one angle here, one possible angle we can get, and we have the trig ratio of sine, we should be able to find theta. And what we need to use here is the inverse sine. So on our calculator, on this calculator we have shift, which gives you a second function, and above sine you have an inverse sine. So theta will equal the inverse sine of 5 over 10, which is the same as a half. So let's look at putting that into our calculator. Turn it on, shift, which is second function, and sine, and you get inverse sine. Put in the fraction, and on the top line we put 5, arrow down, bottom line is 10. Make sure you arrow across to get the cursor in the middle. Close the bracket and push equals, and you get an angle. Because we're finding the inverse sine, you get an angle, and the unit is degrees. So here we have found that theta is 30 degrees. So in the past, I've given you the angle and one side length, and you've been able to find another side length. So if I've given you two side lengths, you should be able to decide which trig ratio to use to find at the angle. So let's have a look at another situation here. What if I said I'm forming a right angle with 5 on the base, so 5 centimetres on the base, and the hypotenuse is going to be 10. So I'm using the same lengths because I'm just trying to keep it quite simple. So because it's the hypotenuse, and there's the angle I formed. There's only one possible angle I can get. And because I've said it is a hypotenuse, it is a right-angled triangle. And there's the right angle. Oops, that's not very good, is it? I might just straighten that up a bit. So much for that accuracy. Okay, so we'll draw that hypotenuse again. It should be on this line. Okay, there it is, 10, and the right angle is formed down here. So it's 10, and here's the right angle. So this is the hypotenuse, this is the opposite, and the other side, labelled 5, is the adjacent. So which ratio links the adjacent and the hypotenuse? The cosine does. Cos theta equals the adjacent over the hypotenuse. So write your ratio down so we can find theta. Substitute the values in. You need to use theta because we don't know the value of that angle. And this here is 5 over 10. So again, I've kept them very simple. So we'll need to find theta, we'll have to find the inverse cosine of 5 over 10. So theta here will equal the inverse cosine of bracket 5 over 10. Now we could simplify it to a half if we wished. Clear the calculator. Again, use shift cosine, and you can see cos inverse, -1. The brackets have opened, put the fraction in, 5 on the top, arrow down, 10 on the denominator. Make sure you arrow across so that the cursor is clearly in the middle. Close the brackets and equals. So the cosine, or the inverse cosine of 5 over 10 is 60 degrees. So here we've found theta equals 60 degrees. Okay, let's try one more. We got some room here. Yeah. So this time we're going to use tan, the tan ratio. So I'm going to make the base of the triangle 6 centimetres, and it's going to form a right angle, and the height of the triangle is going to be also 6 centimetres. So 6 and 6. How many if I join these two lines, how many different angles can I form? Well, I can only form one angle. It's only possible to form one angle because that's the minimum requirements for you to all draw exactly the same triangle. So here we have an angle theta, and I'd like us to find that. So opposite that given angle is the opposite side length. Adjacent, or next to that, is the adjacent side length, and the other one, opposite the right angle, is the hypotenuse. And that's the tan ratio because it doesn't involve the hypotenuse, it only involves the opposite over the adjacent. So tan theta equals the opposite over the adjacent. Okay. Let's substitute the values in. Tan theta, we don't know what the angle is 6. Opposite is 6. The adjacent is also 6. 6 divided by 6 equals 1. So tan theta equals 1. So we've got enough information here to be able to find theta, but we will need to use the inverse tan. So theta will equal the inverse tan of 1. So we'll need to use our calculator, clear the calculator. Shift and tan gives you the inverse tan. This time I don't need to use a fraction, but I could if I needed to. I'm just going to put in 1 and close the bracket and push equals. And as you can see, it's 45 degrees. So theta in this case is 45 degrees. So in the past, I've given you a value of an angle and one side length, and you can find another side length. You just have to determine whether the relationship is linked by sine, cos, or tan. Now this time, I'm giving you two side lengths and asking you to find another angle. So again, you need to make sure you use the appropriate trig ratio. And this time you're going to use the inverse of the trig ratio to find theta. So thank you for your attention, and we'll try some harder problems. Bye for now.